Hello, Gen Chem students. We are going to look at Chapter 18 Notes, Day 2 today. Today we're going to be focusing on calculating reaction rates. In the last set of notes, we talked about what reaction rate was. It was the speed of reaction and factors that can affect your reaction rate. Things like temperature, concentration, surface area, and catalyst and inhibitor. So today, as I said, we're going to focus on calculating reaction rate. So let's get started. Reaction rate is usually expressed as a change in the amount of reactant or product per unit of time. Here you see what the equation is for reaction rate. Average rate of products is your change in product concentration over your change in time. We always start with the final product concentration minus the initial product concentration. Final time minus your initial time. Now, rates always have to be positive. Therefore, reactants, we insert this negative sign there because it's going to be your reactant final concentration minus your reactant initial concentration. Well, your reactants are used up over time. So as you're using up those reactants, you have less and less of them. So your reactant final concentration is going to be lower than what your initial concentration is. So you have a negative times a negative, which is going to give you a positive answer. So that's why we insert that negative for reactants there. The triangle in chemistry always stands for change in. So that means change in time. It's just, again, your final time minus your initial time. When we see those brackets stand for molar concentration. Remember, molarity, which we learned in chapter 15, 16, is moles per liter of solution. And that is the common way to calculate concentration for chemistry. So brackets stand for molar concentration, which again is moles per liter. Now, reactions always start off really fast and then they slow down. How come? A good example of this is when you're popping popcorn in the microwave. When you start popping popcorn, at first reaction doesn't really happen yet. You have to add energy to the system, kind of like your activation energy. Once that energy is high enough, the reaction starts occurring. And in the beginning, you have lots of corn kernels. And those kernels start popping. But as time goes on, you have fewer corn kernels, which means you're going to have a slower reaction. Same thing with any other type of reaction. In the beginning, you have lots of reactants, but as those reactants are reacting and used up, the reaction slows down over time. So why does a reaction start fast and slow down? Because you use up the reactants. There's no more reactants left, or they get to be close to zero. All right, so we're going to calculate reaction rate for this given reaction here. Our experimental data is hydrogen gas plus chlorine gas producing 2 hydrogen chloride molecules. So calculating the average reaction rate of hydrogen. Hydrogen, notice, is a reactant. Since it is a reactant, that means to calculate my rate of hydrogen, we are going to include that negative sign, that negative value. For reaction rate, it is your final concentration, so 0.020 molar, minus your initial concentration, 0.030 molar, over your change in time, which is 4 seconds minus 0 seconds. So 4.00 seconds minus 0 seconds. That gives us a negative times negative 0.010 molar over 4.00 seconds. That concentration there comes out to be 0.0025 molar per second. Your unit there is molarity per second. You have 2 sig figs in your answer because this number up top here has 2 sig figs and the bottom number has 3 sig figs. So fewest number of sig figs in that answer is 2, 0.0025 molar per second. And the negative times a negative gives you a positive rate. The next problem that we're going to look at is chlorine. So we're going to calculate the reaction rate of chlorine. Now notice chlorine is also a reactant, which means we are going to include the negative value here again. For chlorine, its final concentration is 0.040 molar minus its initial concentration of 0.050 molar over your change in time, which is 4.00 seconds minus the 0 seconds again. So that negative carries over, and 0.040 minus 0.050 is negative 0.010 molar over 4.00 seconds again. So we end up with the same rate for chlorine, 0.0025 molar per second. The last reaction rate problem we're going to look at is for hydrochloric acid. Hydrochloric acid is a product. So for products, you do not need the negative sign. It is only for reactants because reactant concentration goes down over time. Product concentration, notice, goes up over time. So final concentration of HCl is right here. It is 0.020 molar minus your initial concentration of 0 molar divided by your change in time, 4.00 seconds minus 0 seconds again. So what we end up with here is 0.020 molar over 4.00 seconds. And if I divide that, I get 0.004, but I need 2 sig figs, so I'm going to add a 0 on to the end of this, molar per second. And I typed that into my calculator wrong. I noticed that when I was looking at my answer, because I'm like, that doesn't make sense. That should be a 5, 0.0050 molar per second. That is it for reaction rate notes today. You're going to need these notes as well as the notes from day 1 in order to complete your homework assignment for today.